the number of toes and like the pattern of teeth just make them lagomorphs, and the position of the ears is like, all right, well, can't argue with that. I'm going to give you the 4 points that you can't argue with on climate science. And I'm sorry, I'm going to skip around study goals, so maybe I'll remember where I am. Maybe I won't. I remember that albedo was in study goal number 18. And we left off here, right?
Yeah.
Sunlight is reflected away by shiny stuff. That's albedo, measuring the shininess. And other sunlight is absorbed by the earth. Everybody knows because sweatshirt out in the sun. If your color absorbs more sunlight, you make more heat. This is not tricky science, I swear. And there are gases in our atmosphere which wobble. Did I show you this? So like H2O or CO2 or maybe CH234, methane. Methane is really wobbly. You can kind of see why. Or maybe sulfur hexafluoride, SF6. That's 20,000 times wobblier, so I just can't do that.
Try.
Well, I need 6 things added on too, so it'd be kind of tricky. But the greenhouse gases, we'll talk about this at another day. You can check if you want, study goal number 19 and 20. Greenhouse gases are those which wobble. They turn heat into kinetic and kinetic back into heat. Like this. You heat them up and their bonds destabilize. And then when those bonds go back to being stable, they give off the heat. You can say that they capture and release heat if you want to be really accurate. You can say that they transform heat into bond instability and then back into heat if you want. Some words you might want to keep in there is bond instability. That's pretty nerdy. But you got to know how to use that thing if you're going to write that down. Or you could just say that they trap heat and give it off. That's fine for greenhouse gases. They trap it and then release heat. We've known that our atmosphere does this since before we had photographs. So I can't show you a picture of Joseph Fourier because he was a corpse before we invented pictures. This science is roughly 200 years old. That there are gases and that they trap heat. And the first guy to build a fake atmosphere and change its temperature was a homie of Charles Darwin. Like literally they knew each other. Tyndall is the name of a bunch of nice places behind Mammoth and June Lake. If anybody's into the backcountry of the Eastern Sierra, because a lot of our big peaks in the Sierra Nevada are named after prominent, historically famous scientists, because we're California and we're red. This guy figured out a long, long time ago that if you had more greenhouse gases, your planet would be hotter. And by the way, he wanted to do that because he thought England was too cold. So when he published his article, he was like, I just wish there was a way to make more of these gases, but the atmosphere is too big.
Tough.
Yeah, because in 1858 he couldn't imagine that we would all have cars burning gasoline and that all of our homes would be heated and that all of our electricity consumption would spike because there was no electricity.
I like that he tried to use global warming as like a heater.
A daydream. He was a nerd in the 1800s, so he liked growing exotic plants. And he's like, wow, people brought me these beautiful flowers from Indonesia, but I can't keep them alive. I just wish we could heat all of the earth. The irony is so ripe.
What was the other guy?
What?
What was the other guy's name again?
Fourier. Or Fourier. I actually don't know how to pronounce his name right. I don't know if it's French or what. It is French. But what do I know?
Nothing.
That guy, Tyndall, he couldn't buy glassware because this was before glassware. So he had to learn metallurgy so that he could make his own metal tubes. To design this famous experiment where he showed that if you heat up the gases, they'll give off heat. And if you add more of the gases, they're going to give off more of the heat. And he's like, all we got to do is change the amount of water in the atmosphere, the amount of CO2 in the atmosphere, the amount of methane in the atmosphere. He didn't know about some gases yet. Because chemistry was pretty weak. He said, all we got to do is raise those gases and we could make Europe nice and warm so that we could grow those beautiful flowers that are coming in from the dark continents. Back when your grandparents were in diapers, there was this guy who walked into the U.S. Congress, House of Chamber of whatever. I can't remember if he spoke to the representatives of the Senate, or both, I don't know. But he gave a big presentation to some congressional committee, and he's like, you know what? I've done some math, and if we keep using the amount of fossil fuels that we're using now, we're going to heat up our planet. Because I found this science from a long time ago. And given how much Americans love their cars and stuff in 1959, like baby boom, he saw the writing on the wall. He's like, I'm pretty sure that we're going to raise the temperature of the planet. And back then, Congress was like, holy crap, man, yeah, you should go keep an eye on that. So this guy became famous.
Wait, so this was the guy who did the...
This is the guy who spoke in front of Congress, and Congress was like, whoa, changing the climate, that sounds horrible. Take some money. Go keep an eye on that. And homeboy built a atmospheric sniffer on top of a volcano on Hawaii. Because that way he could smell the average of the atmosphere because he's not close to any cities. Do you understand why I say this? Hawaii's really far from any big cities. Y'all get that fact? And so on all U.S. territories, the furthest you could get from smokestacks is that Hawaii?
Yeah, that's right. Probably can't see.
I think that's Hawaii. Is that Hawaii?
Whatever.
Who cares? Anyway, he went right there and was 2,000 miles from the closest city. So on all the U.S. territory, that's as far as he could get and start sniffing the atmosphere. And he made this famous thing called the Keeling curve because he had the foresight before current climate deniers were even born to start looking out for climate changing greenhouse gases like CO2. And so he built the basic record because he saw this coming. And you all notice that it goes up and down? Every year it goes up and down? As if the earth was breathing? Does anybody know why the earth breathes?
Because the plants, they take the CO2 from the
Yeah, plants take CO2 from the atmosphere, but isn't it always summer somewhere?
But there's more land in the top atmosphere.
There is more land in the top hemisphere, but what if I told you that it's the opposite? There's also more ocean in the southern hemisphere, and algae uses more CO2. So watch me, you might need to know this. Global CO2 drops during southern spring when we have huge algae blooms around the South Pole. And then we get big algae blooms at the North Pole, but they're not big enough to make up for it, so CO2 levels rise again. There's not a lot of algae at the North Pole, but there's a lot of algae at the South Pole. The ocean does way more photosynthesis than land. Anyway, whatever. That's just a little bit of trivia. That's a study goal somewhere. Number 10. But that's just a neat little bit of trivia. Southern spring is bigger than northern spring.
No, but that doesn't account for how much carbon dioxide.
Right, so that's just the breathing. The overall trend is humans are adding CO2. And by the way, we've also measured all the other greenhouse gases. Because when Charles Keeling started this thing on CO2, there were other scientists that studied other gases. And so what if we have more greenhouse gases? Climate changes all the time. Maybe this is just natural. Perhaps you've heard this one. That climate change is natural? That it happens all the time? That this is not humanity's fault? That is so wrong. Watch this. There was a Serbian mathematician named Milutin Milankovic in the 1940s who had really sharp pencils and a lot of time on his hand. It took us 70 years of computers and satellites to prove he was right. Milutin Milankovic would sit around in Serbia, which I've heard kind of sucks. And he would look into his telescope and take like measurements about like the distance between stuff and like write them all on paper with like 700 significant figures. And then like next year, he'd be like, we're a little bit closer to the moon than we were a year ago. And then like a year later, he'd come back and go, we're a little bit closer still.
How much, like...
The variations are like, I'm not kidding, like hundreds of significant figures, like actually I mean hundreds when I say hundreds. Like this guy was just a crazy nerd, and he like had a hunch early on that the solar system wasn't perfect. And so he like would make all these measurements that were as perfect as he could make them. And then he would look at all these numbers, and he's a mathematician, like a very good mathematician. And he's like, these are changing along a sine wave. And then he would map out the sine wave and be like, whoa, 100,000 year cycles. And he was right. He found 3 cycles. You have to know them. This is a study goal. Number 17, please. Number 1, the shape of the Earth's orbit changes. It's like squeezing and releasing a hula hoop. If you squeeze and release a hula hoop, like this. Squeeze it and it gets long, and then you release it and it goes back to round. And then you squeeze it and it gets long. And so it's gravity from other planets that kind of deforms our orbit a little bit. And Homeboy figured out that every 100,000 years, you go through a full cycle, and that's going to change the planet's exposure to sunlight a little bit. So like you'll have some cooler decades and some warmer decades and some cooler decades along that cycle. Yeah?
This is, I can't read what it says, shape of,
Orbit.
like the gun.
Number 2, he also found that the angle of the Earth's axis changes. I'm going to try my best to show you this, but I might drop the Earth, and if I do, it'll break in half because it's already been taped together once. Watch me. It goes like a little bit more upright, and then a little bit more leaned over, and then a little bit more upright. Every 40,000 years, it goes out and back. And he figured this out by measuring the distance to various constellations and whatnot. Every 40,000 years. And you know, changing the angle would affect how much heat is gained in the north versus the south hemisphere during the seasons. And there's more thermal mass in the south because there's more oceans. So 10 out. And cycle number 3, he found that the Earth's axis also wobbles. Kind of like the way that a quarter does when it slows down, although our planet's not slowing down, it's just like that. So have you all seen that when you like spin a quarter and at the end it starts to go around like that? Axial wobble. The axis of rotation wobbles. Whatever. If you guys want to study the workings of the solar system, this is all basic stuff.
What does the wobble have to do with it?
That all of these have subtle effects on the Earth's climate. They make us a little bit hotter for a few thousand years, or a little bit colder for 100,000 years, or whatever.
Do all planets do this?
I have to assume so, yes. Yeah.
So like, what's the like degree change in like hot 100,000 years and the cold 100,000 years?
How much degrees change?
Yeah.
I don't know, because in addition to what Milankovitch showed, we now know that there are many of these, like dusty areas in the solar system,
Right.
where there's more space dust between us and the sun, so we get sunblock. We know that solar activity spikes and drops, and that's kind of mysterious. There's a lot of theories, but I don't think any of them has won yet to explain solar flaring cycles.
But like, is the change like 5 degrees or is like ice?
Ah, I got you, fam. I got you. When you add all these together, a lot of times they cancel. So you'll have hot from one cycle, but cold from another, so it's just an average period of time. But sometimes they all add up. Like this. You get a pretty hot moment on this one, and a hot moment on this one, and a hot moment on that one at the same time. So that would be an interglacial period in between 2 ice ages. And if you get cold here and cold there and cold here, then you get another ice age. And I want to be really clear about something. We understand what caused all major temperature variations in known history based on natural cycles. We can predict the next ice age. It's not mysterious.
You know where we're at?
I do know where we are. And it's a really well-known phenomenon. We have been, please look up. I'm not making this up. I already wrote this on the board before. Look, barehanded. We've been going downhill for 2,000 to 4,000 years, and we should continue cooling by natural climate variation. So we are kind of dead center in a very gradual temperature drop by natural cycles. When somebody gets on TV and they're like, well, you know, natural climate variation could explain this, they're lying. I don't think that they could get on TV and just plain not know. I think that they're actually just lying. We're in a very subtle, it would not be an ice age anytime soon. You know, there's times when temperature all adds up and it goes downhill pretty fast, and sometimes it goes downhill pretty fast for a long time. We're not in one of those. We're kind of in a long period of pretty mellow kind of climate. except for human activity is giving us the most rapid change in temperature in known history. I got something interesting to show you. Temperatures go up and down all the time, and ice ages don't really cause a lot of extinctions because usually climate changes slowly. So wildlife can adapt. The redwood trees do better to the south, and so the redwood forest starts to shift as the ice caps start to grow. And then when the planet warms up, the ice retreats and the redwood trees start shifting northward. And when you take thousands of years to change by 1 or 2 degrees, it's not really a mass extinction kind of thing. Climate change is usually slower than evolution. Do you understand what I mean by that? Climate change is slower than evolution normally? What's interesting is when you change climate really quickly, wildlife doesn't have enough time to adapt. They just die. That's what happened here, mass extinction. Here, mass extinction. There, greatest mass extinction of all time. Here, mass extinction. Here, mass extinction. And currently, we're just getting started in what will eventually be the biggest mass extinction. Because rapid climate change is the only thing that causes mass extinctions. These ones were volcano, meteor, volcano, meteor, volcano, meteor. And now, we're burning all the rocks. We're like a fake volcano. But how do you even know what the temperature used to be? We've only had thermometers for 200 years. We know because 3 separate things. Please go to study gold. I don't know anymore. Oh my God. Number 11. We have temperature records that go back right now about 60 million years. But you didn't even have a thermometer 60 million years ago. Ooh. I'm sorry that you have to witness this. I'm having a debate with somebody who's not here. Because I'm a 42-year-old man, and every time I see somebody on the news, I just like save up all the hate for the time I get to lecture you.
Yay.
Yeah, I know. Number 1, there's these things called ice cores. There's 2 homies using a really big drill bit to drill a hole in the South Pole snow. Here is a highly qualified scientist who works at the South Pole and is a career professional, and every time I see her, I just can't help but notice that she's also really beautiful. Because I'm trash and I objectify women. And that ice core that she's looking at has little slices. You can see it's got layers with more dust and less dust. Because snow does something interesting. When snow piles up on snow, piles up on snow, piles up on snow, the weight of the snow starts to squeeze the bottom into ice. So if you go to a place that's always cold, like the South Pole has had snow nonstop for like 11 million years. So if you go to a place that's always piling snow, then you can find ice which goes back really far, and you can tell how old it is because that dust has carbon, and you can carbon date the dust. Have you heard of carbon dating? The ratio of isotopes of carbon? You're supposed to learn about this sometime, I think. Life science. And raise your hand if you've ever been to like a deli where somebody had like a big log of meat and they go zing, 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 zing on a deli slicer that's a really sharp big blade that slices thin pieces of usually bologna. So imagine if you used a really fancy deli slicer to take a piece of that ice, you put it inside of a vacuum, let it melt, you don't want the water, You can save all that dust for carbon dating that time sample, and then those little tiny air bubbles are the atmosphere from that many years ago. And it gets better. In those air bubbles, you have a different mix of gases depending on temperature. Because some gases respond to heat more than others. And you get to make these temperature records based on the relative abundance of gases, which tells you the temperature in that little bubble of atmosphere. My homie Joel got his PhD doing one of these. He was in charge of like 8 to 10,000 years ago in Greenland. That was his ice samples. But people do these measurements in the South Pole, and the Alps, and the Himalaya, and the Sierra Nevada, up in the Alaskan range, whatever, and they just measure all the ice, and they figure out how old it is, and what gases were there, and what temperature that was. And please look up. We can core ice for about 650,000 years. Pretty soon we'll be close to 1 million years. With an accuracy, look at this accuracy. Decade temperature averages of give or take 0.01 degrees Celsius. That's a lot of accuracy. But we can go a lot further. There's this thing called paleolimnology. Anybody know what paleo is? Let's start easy. What's ology?
Study.
Good. What's paleo?
Fossils.
Close. Colder. Old life. Anybody know limnos?
No, limnos.
Yes, but you don't know limnos. That's a lake. Using lakes to study past life. Paleolimnology. There are nerds who do this for a living. You can go to really big, deep lakes like Lake Tanganyika. It's the skinny one right there. There it is. Lake Tanganyika. It's really old and really deep.
Where?
It's in the Rift Valley of Africa. Boop. It's right there.
Sure.
It's where they found Lucy.
Oh.
Earliest hominid from the 1950s, important, the Leakey family. And at the bottom of that lake, there's sediment that's been piling up for 11 million years. That lake is really old, yes. And so that lake has been catching dust, and that dust has to go through such a deep lake that by the time it reaches the bottom, there's no life down there or anything. It just piles up dust. And in that dust, you can notice patterns as long as you study these. Anybody know what they are? Pollen. So every species has different pollen. Look at all this science. Because you don't want your sunflower to get pollinated by a pine tree. So pollen is unique to each species. And there are nerds who can read pollen. They look at the pollen and they're like, oh, that's a pine tree. And they go, oh, that's a sunflower.
Bottom right looks like the coronavirus.
Everything looks like the coronavirus right now. Right now, everything looks like coronavirus to me. I'm so afraid. So when you notice which plants were around the lake, you can tell the temperature around the lake at that time. And when you do this at all the planet's lakes, you can be like up and down temperatures, global averages. Going back about 10 million years, we can give you century averages with about a 0.1 degree accuracy. And I don't have slides to show you, but I do have posters. Please look back here. There's this project called ANDRIL, the Antarctica Drilling Project, where they drill through the South Pole into the bottom of the ocean, and they measure the thickness of shells, they measure which diatomaceous algae was there, they measure the amount of methane to carbon ratio in organic sediments, whatever. Please look up in ocean deposits. We can go back 20 million years now, and sometime in the future we're going to get up to 50 million years with a little bit less accuracy.
So that's ocean deposits?
Yeah. But these are, you know, kind of like we've had a thermometer for a long ass time. Well, yeah. Oh, an accuracy of 0.2 degrees Celsius century averages. Oh, so they look at diatomaceous algae, and they look at shells of bivalves, because the growth rate of shells tells you how much CO2 was in the ocean, and then like I don't know, man, there's like so much science here I don't understand. And check it out, kids, we do know what climate does naturally, and something weird is happening. Because please look up. Here's where global temperatures have been the last 12,000 years. The last ice age finished with a rapid warming, and then temperatures were pretty flat for about 5,000 years, and then temperatures started to go downhill a little bit. And we can tell that temperatures should keep going down for a while, but right around the time that we started burning a lot of fossil fuels, temperatures stopped going down and started going up really fast. Look how steep that purple line is. This was like 13 years ago. By now, that purple line is like up here. By the time you're 42, that purple line will probably be up there. And you can't tell me that looks like something natural. Because you can see how much natural temperature change was before humans came along. Temperatures don't change that fast. You know when they change that fast?
Never.
When the rocks blow up.
Extinctions.
Yeah.
I mean, technically, we are blowing up the rocks.
Mm-hmm. Yeah, we are. Nothing secret about it. Look, I want to show everybody a couple of things because I'm arguing with somebody who's not here, and I just want you to be in the room. When people talk about climate science, I don't care what you believe or don't believe. You're allowed to believe whatever you want, but the science is really straightforward and really simple and really, really, really clear. Like saying you don't believe in rabbits, like you could say that, but we know what rabbits are. Sorry. People's lives depend on it. So me saying I don't believe in rabbits is harmless. Whatever, wacky guy. Look at all that body hair, you can't be normal. Hey, but when people say they don't believe in climate science, like they're hurting people. That hurts people. Like that, people die from climate issues. Like that's an affront to the human dignity of other people. So I don't care if you believe in rabbits, but you can't say you don't believe in this because lives depend on it. We started tracking carbon a long ass time ago, and we actually have also tracked all the other greenhouse gases. And when you add them all together, it's the only way to explain our recent temperature changes. That's a really important detail. I'd like to explain what this graph shows you. It's an extremely famous graph. Somewhere around 12,000 people worked on this graph for somewhere around 30 years, if you count all the people who contributed to the final algorithm. This graph is a really big deal. The blue line shows you how climate changes by all known natural forces. The blue line explains natural changes in climate. And then, if you add all of the man-made greenhouse gases to what's natural, you get the pink line. Pink is natural plus humans. And the black line does not fall in natural forces. The record of temperature cannot be explained by natural climate factors. The record of temperature falls dead center in nature plus humans. That's the pink one. It falls dead center in nature plus humans on all the continents' temperature records, on the total of all land, on the total of all oceans, and on the total of all measures of temperature. So you can graph in little pieces, in big pieces, or the entire world. And the only explanation for temperature records is not nature, but nature and humans combined. This graph was published, I believe, 16 years ago. By today, the pink bar and the blue bar have narrowed, meaning we have better explanations of temperature factors. The black line has continued to spike upward, and the pink has really narrowed to explain that the only way that you can talk about current temperatures is that humans are responsible for changing climate. There is no better explanation. Yes?
Why did it take so long to make that graph? Like, what research went into it?
A lot of research wasn't trying to make this graph. It was just understanding records and understanding nature. We can go back 200 years for people who helped with this, just by understanding how gases work and how climate works. The actual project to build the graph took about a decade, I believe. Give or take, depends how big it was. Like, I think the project grew about 6 years before they made it.
On the AP test, would they ever give us like a graph or something like that we have to analyze and say like why?
Analyzing graphs is on every AP test. This particular one, I doubt it. I can only spend a few minutes talking about climate science just to make sure we shake off the whole like belief issue. But honestly, I doubt that this particular matter would be on the AP test. I want to show you something. There are people who say they're still waiting for evidence, but the evidence is pretty overwhelming. Basically, anything you want to look at to measure climate change. You can look at anything you want. It shows that there is rapid climate change. This is ocean heat content. This is sea level. This is which parts of the world have absorbed all the heat. And this matches predictions because water holds more heat than land. Arctic temperatures for 2,000 years. The amount of ice in the Arctic the last 40, and now we're up to 50. I just don't have the current graph. The mass of the Arctic for the longest period back until recent years. The rate of melting in Greenland. The total mass of ice in Greenland. Changes in global currents. Global temperature for 160 measured a different way for 12,000. And there's actually people who are like, well, you know, some scientists, they're not convinced. Show me which ones. Because we study that too. Who doesn't agree? I'm curious about who.
I have a question about why global warming would occur when Jesus returns.
He brings the fires of hell to
Fire and brimstone, young lady.
I am Jewish.
Your loss. Sorry, Hobie, I don't care. Okay, watch this one. Watch this one.
Hate crime.
That's probably a hate crime.
I'm
God.
not gonna sue.
I'm so bad at this.
Me and my Jewish brothers.
You can ask just all science. Like if you're just any type of scientist, Green says, yes, humans are primarily responsible for climate change. But if you focus on climate scientists, like when you rule out the physicists and like the foot surgeons, and you get to like climate scientists, that's 99% agree that humans are primarily responsible. But don't just trust this study. Don't just trust this study. It's been studied repeatedly. And by the way, there was a meta-study of studies, boom, that says every time we look, a majority of scientists relevant in the field believe that humans are primarily responsible for changes in climate. In case anybody's curious, members of the American Geology and Meteorology Union and Society, whatever, the most published climate scientists, the most frequently published climate scientists, scientists who publish on climate change, climatologists, earth science faculty, climate scientists, and again, members of the AGUAMS, all, no matter how we sample it, scientists are primarily convinced. But you know what's wacky? The public is not. Because when you watch the news, you can't just have one side on the news. You all realize that. The news has to show both points of view. They don't get to say who's right and wrong, unless they're talking about opinions. So they gotta be like, here's a guy who disagrees. Strangely, in the United States, our media coverage usually shows somebody who disagrees, and that basically mirrors the percentage of Americans who doubt humans are primarily responsible for changing climate.
74% say no.
Yeah, that number's changed a little bit.
I mean, we live in Santa Barbara.
Yeah, we live in Santa Barbara. Yeah. Roughly half of Americans have a personal dialogue with their creator. Like they hear the voice of their creator.
What do you mean creator?
Well, they have a different one, but
God, though?
Yes.
Like religion?
they're God, yeah. Here are the four. Here are the four basics that I do need you to know. You should probably write this down. There are like four basics of climate science that are all straightforward. Like the four basics, you can have a part in all of them. The four basics are, number one, there are greenhouse gases. You know, some molecules in the atmosphere accept and give off heat. Within a couple of years, I'm going to have an apparatus to demonstrate this. There are some gases which, you know, when you heat them up, they just stay hot. They give off more heat than other gases. Number two, that's why we have a greenhouse effect. That's what gives back some of our heat to the planet. We're like wearing a sweater. We keep some of the heat in. It's called the greenhouse effect. It's normal, it's good.
We couldn't live without it.
Couldn't live without it. And number three, humans are adding to those gases. You can measure that too. So if you add more of the gases, we're going to get more heat. Number four, humans are warming the planet. Everything I just said is really old science. I can't believe that people say the science is shaky. Like that, It's not.
It's besides it.
Like, imagine if you went to the dentist and you're like, I don't believe in the science of Novocaine. Or you like walk out on a bridge and you're like, I don't believe in the science of engineering this bridge. And you start like cutting the cables. Like, that's literally what we're doing about climate. Like, what do I know about engineering? Like, thank God that there's some dude that knows how to build, or some lady that knows how to build a bridge. I appreciate that. Thank you very much, lady. But like, if I went out there with like some big like cable cutters and was like, nah, I don't believe in engineering, I'm just gonna cut all these, you'd be like, bro, what? You don't do that.
Probably be taken to a psych ward.
Meanwhile, we elect people who do this with our climate policy. Somebody's like, vote for me, I'll cut all the cables off your bridge. And we're like, yeah, that guy! Like, how?
Our 8th grade science teacher tried to tell us that climate change didn't exist.
No,
Like-
he didn't. He tried to tell us that overpopulation was the larger issue.
I want you to always remember, because he was an older person, I want you to always remember that I told you there's no rabbits, but that doesn't make me right. I want to be memorably wrong on the rabbit issue.
You're memorably wrong in a lot of ways.
To be
I
fair,
will whoop your ass, and I'm memorably right about that.
to be fair,
Uh,
it's the same guy that drinks 5 times a year. So
But, show me where I'm wrong on this one.
He's on camera.
Hey, it's fun to show me wrong, right? We can do that all the time. Show me how I'm wrong on this one.
Telling you you're gonna whoop a student's ass on camera.
That may have been wrong.
We're taking that one to court.
Now look, I gotta remind you that predicting the future is difficult. We have these things called global climate models. They're called GCMs. This is a study goal, I think. Yeah, number 11. Our climate models used to be really simple. There was only like 2 or 3 variables. So back when we started with computers, it was pretty tough to predict climate because we only had like rain and CO2. That's it. And then like our climate models have gotten smarter. So we added land, we added clouds, we added ice, that's albedo. Then we added like gas exchange to water. Then we added natural sources of gases and man-made sources of gases and circulation in the ocean. And we've been adding, those are the names of models, we've been adding more and more details. Like what does the deep ocean do? And what do particulates in the air do? And we've been adding like, you know, chemistry that happens in the atmosphere. We've made really complicated models that are starting to get really detailed. Because we used to run these on just a few blocks of the earth, but now we're like, you know, like pixels in an image. We used to have like really pixelated images, but now we have like really fine modeling. And I'm sorry to tell you this, when you test against the past, our models are accurate. And then when you use them to predict the future, all scenarios show continued and severe heating. If humans disappear from the face of the earth right now, we still get 450 years of rising temperatures. Just from what we've done already, we're going to have continued rising temperatures. This is not a joke. Like, lives depend on this. Those people who take the money to lie to you, they really got to look in the mirror.
So there's like a bunch of things going around that's like, if we don't stop climate change, like in 10 years we're all gonna die, basically. Like, what, like when, like do we know the point where this will be not?
I can answer this really easily, and I have to remind you that it's not about you.
Well,
I know. And so, since I know you know that, you'll die a happy American white lady. Maybe you'll be lucky enough to die fat like me. I'm gonna die fine. Climate change is not my problem. I'm not worried about this. I'm on the right side of the wall. I got a bunch of guns. I got a bunch of food. Booyah! And in many ways, that's our American reality. I make a joke about me, but that's actually us. Meanwhile, people have been dying to climate change for 40 years. Not me. And so the number of people who will die due to climate change rises dramatically every year. It'll probably never reach you. In America, there is no temperature that would be too critical. You imagine a dystopian future where the climate spiked by a ton of degrees, and America will just have gas masks and flying cars or whatever, and we'll be fine. We'll just have more air conditioning. Like, I don't know, dude, like, that question doesn't make sense, because you gotta remember that there's winners and losers all the time. So we're always gonna be on the winning team, I think.
Well, I mean, more in the sense of, like, just, like, if things continue the way they are, like, what, until, like, I don't know, like, there's so many chemicals in here that it's toxic and shit like that. Like, not actual.
You're gonna die fat and happy, don't worry about it. Bye, children!